Good morning. Today is June 1st, 2024. Today we're going to talk about electromagnetism. And then we're going to continue talking about electrical flux. So last time we talking about the electrical field is perpendicular to the surface, right? But today we're going to talk about more general case. Like if I twist it this way. So let's say this is a plane 4, right? So the plane 4, the direction of the plane is that way. And then let's say the angle formed by the electrical field and the plane 4 is theta. So that's a random case. So I put it right here. So let me draw this again. So again, this is a cube with the side of A. This is a plane 1. This is a plane 2. This is a plane 3. This is plane 4. Top is 5. Bottom is 6. Now, let's say this is our electric field, E. We're specifically talking about the plane 4. Let's say the direction of the plane 4 is like that, and then that's the angle between them, right? So the phi 4, based on our discussion last time, is E dot A is magnitude of E times magnitude of A cosine theta, where theta is the angle between electric field and the plane. So we know E with no arrow, that means the magnitude. The A will be the area of this plane. We know the side is A, so the area is A squared, and then cosine theta. Okay? So what about another one? I'm sorry, this is for the phi E4. What about phi E3? Which means this guy right here. Can you see that's a 3? Okay, so let's review what we had for plane 4. That's the angle theta, right? But what about plane 3? Plane 3, the angle, the direction of the plane is pointing that direction, but the electric field is that direction. So the angle theta will be that angle, right? So we know this angle from here, the theta we have, right? So that angle will be 180 degree, subtract that, right? So basically, if we have angle is theta right here, this angle right here is 180 degree, subtract theta. Okay, so let's say that would be E dot A, and then magnitude of E times magnitude of A, and then here the angle will be 180 degree, subtract theta. Now, before move further, we want to review a trig identity. So if we have two angle cosine A subtract B, that will be cosine A cosine B. Notice we started with subtraction, here got to be addition, sine A, sine B. So this is the formula you have to memorize. Okay, now continue calculation phi E3. So that will be E, right? The magnitude A, again, will be A squared, since for 3, the side length is also A. A squared. And then this, we have to use the trig identity. It's going to be cosine A, which is 180 degree, cosine B, which is cosine theta, plus sine A will be sine 180 degree times sine theta. Okay, and then that will be E A squared. So cosine 180 degrees is equal to -1. And then this is cosine theta. So it's going to be negative cosine theta. Sine 180 degrees is equal to 0. 0 times anything is going to be 0. So the whole thing will be negative E A squared cosine theta. Okay? So let's look at another angle. What about the, another case. What about the plane number 1, theta phi E1? We try to calculate the flux when electrical field passing through plane 1. So look at this. This is our plane 1, right? So this is the plane 1. And then the direction of the plane goes like that, right? So that's the angle between that. But notice the angle from here to here is theta. And then this is a perpendicular, right? So the angle between the plane 1 and the electrical field that actually equal to 90 degree plus theta. Okay, so that would be E dot A, and then cosine 90 degree plus theta. Okay, now let's review another trig identity. We have cosine A plus B. That will be cosine A cosine B. Notice we have plus right here, so it got to be subtraction. Subtract sine A, sine B. Again, this is another formula I want you guys to memorize. It is very helpful. And then let's recalculate phi theta 1. So that would be magnitude of E times magnitude of A. Again, the side length is A, so the area is A squared. And then we have to plug in this. So cosine A would be cosine 90 degree, cosine B would be cosine theta, and then subtract sine A would be sine 90 degree, and then sine B would be sine theta. And then that would be EA squared. We know cosine 90 degrees is 0. So 0 times anything would be 0. Sine 90 degrees 1, so subtract sine theta. Simplify this a little bit, we'll get a negative EA squared sine theta. Now we want to calculate the electrical flux when the electric field passing through plane 2. Okay, and then that's the direction of the plane 2. Notice this is the angle theta that we started with. But what we're looking at is this angle right here. So in other words, that's the case, right? We know this angle is theta. We try to figure out what is that angle. That actually is 90 degrees subtract theta. Okay? So that is phi E2, that is absolute value of E times absolute value of A times cosine this angle, 90 degrees subtract theta. And then magnitude of E, just E, magnitude of A will be A squared. And then here we have to use this formula again. That would be cosine 90 degrees. And then cosine B will be cosine theta. Since this is subtraction started with, we have to use addition. And then sine 90 degrees sine theta. Now we know cosine 90 degrees is 0. So 0 times anything is 0. Sine 90 degrees is 1. So plus sine theta. So the end result is A squared sine theta. Okay. So let's look at the last two planes. One is plane 5, another one is plane 6, which is the bottom. So for the phi E5, look at the direction of the plane 5 is that. So it doesn't matter how random the electric field is, but it is always perpendicular with plane 5. So that would be E A times cosine 90 degrees. So that is 0, since cosine 90 degrees is 0. Similarly, the E phi 6, which is the bottom line, because the direction of the plane is going like that, and then again it is 90 degrees. So phi E6 would be E A cosine 90 degrees, again is 0. Now if we try to find the total flux that passing through all the different planes, we are going to add them together. E2 plus phi E3 plus phi E4 plus phi E5 plus phi E6. So that would be, what is our 1? Our 1 is right here, is negative EA squared sine theta phi E2. Where's the phi E2? Oh, phi E2 is right here. It's this guy right here. So plus EA squared sine theta. What about phi E3? Phi E3 is this guy right here. It's negative EA squared cosine theta. Phi E4 is this one, is EA squared cosine theta plus 0, which is phi E5. And then plus phi E6 is 0. Notice this one, they cancel out. This one negative, one positive, so the whole thing is 0. So the result is very, very important. Keep that in mind. It seems like it doesn't matter whether the electric field perpendicular to a closed surface or not, right? As long as the electric field passing through the enclosed geometric shape, it seems like the total flux is always 0. Again, when we're talking about Gaussian law later on, we will get a much better understanding. But right now, keep that in mind. And then that's all I want to share with you guys for today. Thank you, and see you next time. Bye bye.